I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends, and subscribe. For person wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below. Welcome back to Geography World channel. For this video, we'll be looking at the May-June 2019 CSEC Geography Paper 2. For this video, we will look more closely at question number 2 that deals with the natural or the physical system. So, question number 2, it shows us a diagram which basically shows the plate boundaries and we're to answer the questions that follow. So let me zoom in a bit so you can see clearer. So that is the picture that is given. Now part A asks that you name the plates labeled or shown at A and C. So the plate labeled at A, now the arrow, it shows you the plate movement, right? So the plate labeled A is a divergent plate boundary because both plates are pulling away from each other. Plate labeled at C, it is a convergent plate boundaries because the plates, they're moving towards each other where they will form fold mountains. Now part 2 asks what type of mountain is formed at B. Now at B, in order to determine the type of mountain that is formed, you need to look at the type of plate. So you have two plates coming towards each other, which means that there's a collision zone. And once you have a collision zone, it means that fold mountains will be formed within that region. Part 3 asks us to state one landform associated with the plate boundary shown at A. So at A, that's where we have the divergent plate boundaries. And that divergent plate boundaries, we can have rift valleys being developed, we can have volcanoes or mid-oceanic ridges being developed. So for question number part 3, at divergent plate boundaries, we can have rift valleys developing, volcanoes or mid-oceanic ridges. For part 4, it asks us to state the name of one active volcano located in the Caribbean. So you're to just state one active volcano in the Caribbean. So I'm going to give you a list. So you can state either La Soufriere in St. Vincent and the Grenadines. You can talk about Soufriere Hills in Montserrat. You can talk about Kikem Jenny off the coast of Grenada. Or Mount Pele in Martinique. You have the Nevis Peak in Nevis and Le Grande Soufriere in Guadeloupe. So anyone, just list anyone and the mark is yours. I would recommend though that candidates stick to the more recent volcanoes, so like Soufriere Hills and La Soufriere in St. Vincent. You can use or list those one. Part B. Question B, part 1 asks us to describe how each of the following feature is formed. Now a sill. Now sills are basically small intrusions along the bedding layers and they form horizontal layers of magma. Now an example of a sill is the Newcastle Sill in Jamaica. Now sills are formed when magma intrudes between rock layers and cool to form a horizontal or gentle dipping sheet of igneous rock. Dikes are diagonal or vertical intrusions across the bedding planes. Now they basically form vertical walls of magma, right? So the dike, they are formed when molten magma flows upward through near vertical cracks towards the Earth's surface and cools to form a sheet-like igneous intrusion that we call a dike. So the dike, they are basically formed when the molten material flows upward through the vertical cracks towards the Earth's surface and cools to form a sheet-like igneous intrusion called a dike, right? So the dike is vertical while the sill is horizontal. Part 2 of the question asks us to describe what happens when a continental plate meets an oceanic plate. Now, at convergent plate boundaries, you have two plates coming towards each other. Now, when a continental and an oceanic plate meets, the continental crust or plate will float over the oceanic plate, while the oceanic crust will subduct into the mantle, where the extremely high temperature will force the oceanic crust to melt and turn to magma. Now that magma will return to the earth as lava through volcanic island arcs that will develop along the subduction zone. The continental plate floats over the oceanic crust because it is easier and lighter than the oceanic crust. So the oceanic crust is denser than the continental crust. So the continental crust will float over the oceanic crust while the oceanic crust will subduct into the mantle. Part C asks us to explain why the shape of a basic lava cone is different from the shape of an acid lava cone. Now, a basic lava is basically low in silica content, and this makes it non-acidic and very runny. Hence, it flows for a long distance before it solidifies. Now, basic lava, they solidify to form shield volcanoes, and we know that the shield volcanoes are the largest volcanoes on the earth, and they are the ones that actually look like a volcano. Now, they are wide volcanoes with shallow slope inside. So because of the basic lava, they have gentle sides as the basic lava flows for a very long distance before it solidifies. Now, they are formed at divergent plate boundaries. So for the basic lava cone, because of the low silica content, the lava is very runny, is very thin and runny. So it flows to great distance before it cools. Hence the reason why it creates gentle sloping volcanoes or gentle sloping sides, right? Now for the acid lava, it is very high in silica content, which makes it very viscous or thick. Now, because of its viscous or thickness, it prevents it from flowing to great distance. Now, the acid lava, they create steep-sided domes such as composite or stratovolcanoes. Now, the composite volcanoes are cone-shaped volcanoes, and they're usually built from many layers of ash, lava, and other volcanic materials. Now, the composite volcanoes, they are built of layers of viscous materials rather than fluid lava, right? Because they tend to form really tall peaks rather than round cones. Now, with the acid lava, it creates very steep-sided slopes because the acid lava, because of how thick it is, it prevents it from flowing to great distance before cooling, so it creates very steep-sided slopes, right? And this is usually found at convergent plate boundaries. Let's look at question D. Now, question D asks that you explain the causes of earthquakes at convergent and transform plate boundaries. So, you're to explain the causes of earthquake at convergent and transform plate boundaries. Now, convergent plate boundaries, earthquakes develop when two plates crash or collide. Good. So, the colliding of the two plates causes an earthquake. So, also at convergent plate boundaries, at the subduction zone where the oceanic crust is sinking into the mantle, the rubbing of the two plates can trigger an earthquake. Now imagine you're driving your car and your friend is driving from the opposite direction and both cars hit each other. It's going to trigger off a shaking, right? So the cars are going to be shaking. So at convergent plate boundaries, where two plates meet or collide, that is how an earthquake is created at convergent plate boundaries. Now at transform plate boundaries, two plates are sliding past each other. Now, as the plates rub against each other, they may eventually stick onto each other where pressure and stress is built up. Now, when enough pressure and stress is built up, the plates will pull apart or snap apart, and once they snap apart, the energy or the stress that is built up will result in an earthquake. Now, at transform plate boundaries, these are where we have the most dangerous earthquakes being formed. So the two plates are sliding past each other because the surfaces are not smooth. They become locked onto each other sometimes, and once they become locked onto each other, pressure and stress will build up. Now, once enough pressure and stress is built up, the plates will snap apart or pull apart, and this will basically trigger a major earthquake. I want to thank all my viewers and subscribers from the different Caribbean islands. Please remember to share with friends. We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye.